Welcome to SCARLETT. SCARLETT, which stands for Scalable and Reconfigurable Electronics Platforms and Tools, is an EC-funded FP7 First Call project coordinated by Thales Avionics. This presentation will provide you with a general understanding of the Early Validation Tool, or EVT. EVT is the tool dedicated to the network design architect to size the platform in terms of number of IMA resources according to the aircraft functions that are to be hosted. For a better understanding of this presentation, it is advised to first go through the IMA incremental process presentation. As one remembers, IMA is a distributed solution to host multiple functions on common platform resources. Typically, a set of functions can be hosted on the same core processing module. Because we are in a world of aeronautics, determinism of this allocation shall be ensured with great care. Even if the IMA incremental process proposes the usage domain concept as a contract between the function resources needs and the offered platform resources, how can one allocate the exact platform resources that is needed for the set of hosted function so to size the overall platform in terms of number and types of modules? In other words, how to be sure the platform doesn't embed an extra module due to its incorrect sizing, thus leading to extra weight and power consumption. This is where the early validation tool is of great help. Resource management and allocation is the key concern to master the incremental process, mainly because resource is the source of dependencies, i.e. between functions. Resource is the focus of usage domain or UD rules as per IMA incremental process. Platform resource allocation or budget policy strategy is the way to manage, control and limit dependencies and reach full incremental capacity of the platform. Individual budget allocation to function results from the combination of 3 points of view: the user or function needs, the platform capacities, and the spare policy. It has to be validated very early because these are the keys on which the incremental process relies. And those pieces of information comes from 3 different actors: the function supplier, the platform supplier, and the aircraft manufacturer. If we consider a 4-step continuous development process, from the bid phase to the qualification, it is understood that there is a relationship between the applications development process and the platform development process, and there is a need for an increase in maturity of the usage domain all along the development process. Early validation tool is the go-between for the early stages of both development processes. During the bid phase, using models of platform usage domain and application needs to validate general platform sizing. And during the preliminary design, using preliminary usage domain definition to validate allocated budget against function needs and spare policy. Early validation tool can also be of benefit in the last stage of the development process, especially when it comes to mitigate risks of late discovery of issues relative to the incremental process, i.e. late budget changes. Early validation tool shall be seen as a continuous risk mitigator all over the development of an IMA solution based on the incremental process rather than a one-shot use that would serve the bid phase. Let's now have a look at the general principle of early validation. EVT manages 3 separate types of data. Functional needs, coming from either applications, for example processing and memory needs, system or aircraft communications between functions. Capabilities, coming from platform design or specifications, processing capability, memory sizing, I/O capabilities, network capabilities, etc. Resource allocations, resulting from a compromise between needs, capabilities and spare policy, potentially evolving during development process. Representations of resources is organized on a type-per-type basis. Types of resources presentation currently offered are processing and memory, network, and input and output. All representations take into account modeled usage domain. The representation of the spare policy is attached to each of the three types of data. Moreover, two types of spare can be represented. The local spare, dedicated to the function supplier. It allows evolution of an application independently from others. And the global spare, dedicated to the module integrator. It allows to install new applications onto the platform. From the point where various representations of resource usage are satisfactory, connections are possible in two ways to configure generation tools. To avoid keying parameters that already exists in EVT, and to allow for a replay of EV phase from existing configurations. Let's see how the tool is working. This is the architecture view of EVT. In our example, the proposed distributed architecture is made of 4 computing modules or CPM, including processors, 4 remote data concentrators or RDC, including I/O engines. Please note, it is possible to define any type of equipment including 5 types of engines: a processor engine, an I/O engine, a switch engine, a gateway engine, and graphic engine. Let's have a deeper look at processing representation. From the architecture view, let's select the first CPM and click on the processor icon. We will access the processing views for memory and time resource validation. This is the time representation view for a given processor. It provides processing capability through performance factors, real-time structure, MIF and MAF, global spare and amount of resource used, needs, allocation and local spare per application, constraints of usage domain, partition switch. Then from this time, processing time is now possible by clicking a specific partition to access details related to this partition processing time views. This is the partition time representation. It provides recall of processing capability through performance factors of target. Time allocation provided by module integrator to function supplier. Expression of needs by the function supplier using a function supplier reference platform. Execution time, WCET, computed on target providing algorithmic I/O time and WCET certification margin. Local spare. Let's go back to the time representation view for a given processor. From here, it is possible by clicking on the Memory tab to access to processing views for memory resource validation. This memory representation view provides memory capacity regarding 3 types of memory: code, either flash or RAM, data, saved data, global spare and amount of used resource, needs, allocation and local spare per application. Let's go back to the architecture view. It is possible by clicking on a Show Processor Allocation of the Visualization menu to access to Global Platform Processing views for memory and time resource validation. The Global Time Platform view provides, for each processor, needs expression, allocation and usage rates, global and local spare. From here, it is possible by clicking on the Memory tab to access the Global Platform Processing views for memory resource. Global Memory Platform view provides, for each processor, needs expression, allocation and usage rates, global and local spare. Let's see how EVT can help for I/O representation. Back to the architecture view, let us select an I/O engine and click on it to access I/O allocation dedicated views. And then click on the Show I/O Allocation to Partition Status entry of menu Visualization to access Global I/O Allocation views. The I/O allocation view per I/O engine provides I/O engine capacity, number of I/O items per I/O item type, I/O items allocated to partitions. By clicking on the symbol representing partitions, one may access the per partition I/O allocation view. I/O allocation view per partition provides partition needs per I/O type, I/O items allocated to partitions. Thank you for listening. This tool has been developed by Thales in the frame of SCARLETT. It's currently being assessed by Airbus Germany. Please visit our website, and should you have any further questions regarding this video presentation, please do not hesitate to contact any of the persons mentioned. Thank you for your attention.